This will be the first video on quadratics. Quadratics are equations that take this form here. Mainly, the main point of this video is going to be to show that these can be represented as a product of linear terms. So first off, let's show what I mean by that. And these can be two different sides here. Okay. Okay, so for one of my sides, I'm going to want it to be a plus b, one side of the rectangle. So I have a length a, and I'm adding length b to it, and that's going to be one side of the rectangle. And then I have one other side of the rectangle will be length c and length d. And my main point here is I want to show that a plus b times c plus d can be shown to be products of the lengths. I can add up products of these lengths, the different combinations of the lengths. So lengths, say that word a bunch of times. All right. A times C is going to be the area of this rectangle. A times D will be the area of this rectangle. And then I have B times C and B times D. So these are the areas of the individual rectangles. And when I multiply these together, I'm talking about area. So a quadratic is always going from length to area. Usually involves an area problem. So we know that if I want to find the area of the whole, I can just add up the individual parts of that whole. In other words, it's going to be a times c plus a times d plus b times c plus b times d. Right. Another way to see this is using the law of distribution. In other words, I'm taking this a times b term and I'm seeing it as just one whole number, and I'm distributing it to the c term here, and I'm multiplying that, and then I distribute the c to each parts of the a, the first term rather. Here, I'll show what I mean by that. If I take a times b, and I want to take that term as a whole and multiply it by c, I can do that. I'll just say times c. And then I want to take a times b and distribute it to d as well. So a plus b multiplied by d. Okay, from here, then I distribute in the c to each one of these terms. And I have ac plus bc. And then I distribute the d into each one of those, and I have AD plus BD. And then so we still have the same answer here. The only difference is these two terms are switched positions. So that's another way you can see it, is we just use the law of distribution twice to arrive to this result here. So let me do a couple of quick examples of that. What if I have x plus 1 times x plus 2? Well, I could see that in the kind of the diagram that I was showing before. If I have x and 1 and then x and 2 as two sides here, two linear terms, x plus 1 and x plus 2, I could just add up the sum of the parts. In other words, x squared plus x plus 2x plus 2. Or I can combine these and see that 2x plus x is 3x. That's going to be, I'll just do both steps. X squared plus 2x plus x plus 2. And these two terms combine, so it's actually x squared plus 3x plus 2. Alright, so that's one simple example. We can actually show this using many more complicated examples as well. I think I have time, so I'll just do one more complicated, slightly more complex example. So let's say 3x plus 1 and then 5x plus 3. So I could show the diagram, and I guess I'll do that real quick. So it doesn't matter about these sides, and the sides aren't going to be right. I'm just going to have a 3x here, a 5x here, a 1, and then a 3. And basically, the area of this rectangle will be the areas of those sides multiplied together, or 15x squared. And then the area of this rectangle will be length 1 times length 5x will be just 5x. And then length 3 times length 3x, or 9x. And then 3 times 1 for this area of that rectangle there. And then I just have to add these up. 15x squared plus 14x plus 3. But that 14x was actually 9x plus 5x. So I'm going to do that real quick. 9x plus 5x plus 3. And really, my whole point is I want to show that the pattern here that we're doing is we're taking the first term and multiplying it by the first term to get that first term there. And we're taking the first term, multiplying it by the last term to get the second term there. And then we're taking the middle terms, and then multiplying those to get that one. And then we're taking the last terms and multiplying it to get that. And then we're adding them all up. And the two middle terms will always combine, depending on if they're in this form. Alright, so this is called the FOIL method. First, outside, inside, last. If you're familiar with that.